Hello all, welcome back to Code Hub. Let us solve the weekly contest 327, and if this is the second problem of the contest, and this is a quite standard problem. Okay, let us solve the problem. The problem is maximal score after applying k operations. So what is the problem states? You are given a zero indexed integer array nums and an integer k. You have a starting score of 0. In one operation, choose an index I such that I is inside the range, and we have to increase your score by nums of I and replace nums of I with seed of nums of I divided by 3. So return the maximum possible score you can attain after applying exactly k operations. So what we want to do is, for each time we want to pick some nums of I, and we want to replace that nums of I with the seals of nums of I divided by 3. So to for each and every time we want to find the maximum element in the array, and it is not possible to each and every time traverse the whole array. So the brute force solution is order of n square, but that is not a good approach because the constraints are 10 power 5. So it will be quite exponential, sorry, it will be quite quadratic. So we want to do in some linear time complexity, or else we have to do it in n log k or k log n. So what we can do is, for each and every time we want to find a maximum element, and that we can do by a priority queue for, and we can get each time we can get a maximum element from that priority queue. So we can make use of the priority queue, and we can get the maximum element, and we can just divide that top element by 3, and if it is going to be not divisible by 3, then we can increment one step with that counter, and we can just put it into our queue. That is the core logic of using priority queue, and we can just maximize the score since we will be taking a maximum element each time in the iteration. So what I will be doing is, I have initialized an answer, and I have also initialized a priority queue, and I have pushed the nums into the priority queue, and I'm checking one condition whether a priority queue is empty or k is greater than 0, because we have to do only k operations, and I'm taking the top element and I'm adding it to my answer. And once I have added, what I will be doing is, I want to find the seal of top by 3, and it can be done easily by these two statements. And first I'm taking the c as top by 3, and if my top is not divisible by 3, then it is going to be some decimal value. Like if I say like 4 by 3, it is going to be something like, let us say 4 by 3. 4 by 3 is something like 1.33, and we need some 4 by 3 as 2. So what I will be doing is, if my 4 by 3 is not divisible, then I will be incrementing C, and I will be popping the priority queue, and if it is greater than 0, then I will be pushing back into my priority queue, and this will be doing for k operations. And the overall time complexity for the solution will be n log n, since there are n elements in the priority queue, and we will be taking each element once, and there will be at most n elements in the priority queue, and for each popping each element, when we pop, is the time complexity is going to be log n. So overall time complexity for the solution will be n log n, and finally we are going to return the answer, and that's it for this problem. And yeah, it gets accepted. Hope you like the solution, and let me know in the comments. Let us see in the next problem of the weekly contest, and until then, bye.